always start saying that you need to look at the heart as the heart of a patient. So these would be, for you guys that are facing me, these would be the right side of the heart, and this is the left side of the heart, okay? These right here, they're appendages of the atrium. They're called auricle. Do you need to know auricles? No.
Just for lecture.
Okay. Yeah, you need to know for the lecture. Okay. So let's start by looking at the heart chambers. So here on the top, you have the right atrium. And arriving at the right atrium, you have the superior vena cava, the inferior vena cava, and you can also see the opening of the coronary sinus. The coronary sinus, oh, we just dropped the valve, atrioventricular valve. The coronary sinus is what receives the blood from all the veins that are draining blood out of the heart. And you see the coronary sinus here. All veins are arriving at the coronary sinus, so you have the deoxygenated blood from the heart itself arriving at the coronary sinus, and here is the opening of the coronary sinus. Okay? So arriving at the right atrium, you have the superior vena cava, inferior vena cava, and the coronary sinus. Here, this mark that you see here, this is the fossa ovalis. That was a hole before you were born, but then it was shut closed when you took your first breath, right? Now, when the blood arrives here in the right atrium, when the atrium contracts, and both atriums contract at the same time, the blood will go to the ventricles. So if you are in the right atrium, the blood will go to the right ventricle. If you are in the left atrium, it will go to the left ventricle. To go from the atria to the ventricles, you have the atrioventricular valve. So you have the right atrioventricular valve, and the left atrioventricular valve fell before. Yeah, it's in her figure. So what these valves, they are folds of endocardium. They are very flexible. So if they were not held down by anything, when the ventricles would contract, these valves would flip up. So you have these tendon-like cords connecting the valve, the cusps of the valve, to a muscle that you have right here called papillary muscle. So the tendon-like cords, they hold the cusps of the valves to the papillary muscle. And when the ventricles contract, then this papillary muscle will contract and hold the cords down, which will hold the valves down, which will close the cusps of the valves. So the blood has only one option, going to the pulmonary trunk or into the aorta if it was ejected from the left ventricle, okay? So because these valves were closed, blood could not go back to the atrium. If these valves don't close properly, the atrioventricular valve don't close properly, then you have regurgitation of blood from the ventricles into the atrium, and that is a problem, right? What closes these valves is actually the pressure of the blood inside the ventricle. Okay, I'm just mixing lecture and lab, but you guys will need to know all this information in the way. So the valve that we have in the right side is also called tricuspid valve because it has 3 cusps, okay? And the valve we have in the left side is also called left atrioventricular valve or bicuspid valve because it has just 2 cusps. So you can either think tricuspid, like you try before you buy, okay? Whatever helps you. And the bicuspid is also called mitral valve. Clinicians love to call this mitral valve. Okay, so inside the ventricles, you have a muscle called trabecula carne that you guys don't need to know about. You just need to know about the muscle that we have inside the atrium. That is in the right atrium that you can see here. That's inside the right atrium, right auricle, and also the left auricle. And the name of this muscle is pectinate muscle. That's what helps you squeeze out the maximum amount of blood from the atria into the ventricles. And then inside the ventricles, you have the trabecula carne, that when the ventricles contract from bottom up, we have all blood being ejected into either the pulmonary trunk, that's where the blood that was inside of the right ventricle goes, and into the aorta, that was the where the blood that was inside of the left ventricle ends up. So because the blood is going against gravity, you need to have valves at the entrance of the pulmonary trunk and valves at the entrance of the aorta. So the one at the entrance of the pulmonary trunk is called pulmonary valve. And the one at the entrance of the aorta is called aortic valve. And they are also called semilunar valves because they look like half moons, so semilunar. Now, here you have the pulmonary trunk. And you can also call it pulmonary artery, which I don't agree, but you can. I think in your list you guys call it pulmonary artery. No? So this is the pulmonary trunk, and when it splits, it becomes the pulmonary artery. Okay? So here you see a pulmonary artery going this direction and one going this direction because you have two lungs, right? So they end up in the lungs, and the only reason why you have lungs, or the main reason why you have lungs, is because you need to get your blood oxygenated. So based on gas exchange, you have the CO2 leaving the blood, and then you have oxygen gets into the blood. And then whatever leaves the heart is an artery, because artery takes blood away from the heart. Whatever arrives at the heart is a vein. So you have here 4 pulmonary veins bringing blood back to the heart and arriving at the left atrium. So arriving at the left atrium, goes to the left ventricle, and then is ejected into the aorta, right? So we can generalize and say that the right side of our heart works with deoxygenated blood, the left side of our heart works with oxygenated blood, okay? So now if you look at the aorta, you have here the aorta, and this is the aortic arch. And you need to remember the ABCs at the aortic arch. The first thing it splits is the brachiocephalic, B, A, B, brachiocephalic. And then you have C, the common carotid, and S is the subclavian. So the brachiocephalic goes to the right, and the common carotid and the subclavian, they go to the left. So this is the left common carotid, and this is the left subclavian. And this brachiocephalic splits into 2. Since it goes to the right, this is the right common carotid, and this is the right subclavian. And I believe that, oh, and which one is this one? Azygous vein, because it's the one that works as collateral circulation for the inferior and superior vena cava, and it arrives here at the superior vena cava. And that was it for the heart.
And the veins are the same.
Which veins are the same?
The coronary veins. The coronary.
Divisions.
Ah, okay. So here you have the brachiocephalic trunk, right? You have the right and the left. And which one is the one coming from the head?
The jugular.
The jugular. And this one that comes from the sides, what do you have in our sides? The subclavian. So you have the right and the left.
So it's called brachiocephalic trunk. But two
Yeah.
of them.
Yeah.
We have two.
You have the right brachiocephalic trunk and the left brachiocephalic trunk. Because brachio means arm and cephalic means head. So you have something that comes from your arm and something that comes from your head. Brachiocephalic trunk.